In this method, I mean in charging by induction, the body never be in contact with each other. Okay, I mean you can also say without touch, right? The body never touch each other. Okay. All right. And now the method of induction of the charging is a type of phenomena which is also known as a temporary electrification. Are you clear or not? In which a body can charge by the help of the another charged body. A body of uncharged body can be charged by the help of the another charged body without get in contact with each other. Are you clear? So please write down electrostatic electrification. Electrostatic induction is a phenomena. Electrostatic induction is a phenomena of temporary electrification of a conductor in which opposite charges appear at its end and similar charges appears at its further end. Okay, let's try to understand it. Suppose that we have a body like this, and this body is neutral. What is the means of the neutral body? A neutral body means the body have a body have both type of charges in equal amount. Are you clear? And now in this body, you can draw like this. The body have both type of charges in equal amount. Then the body is said to be the neutral body. Are you clear? Then how can we make this body like a charged body by the help of the induction? Suppose that we are carrying, it's your step number 2. We are carrying a charged body near this neutral body. Then what will happen here? This is your charged body. We are carrying this body, okay, near this rectangular body, but this body and this rectangular body never be in contact with each other. I mean they never get touch each other, causing which the charge available upon this body gets polarized. Okay, gets polarized due to this body. The negative charge start to attract towards the body, and the positive charge start to repel, like this. Are you clear? Due to which you can look at here, this positive and negative charges, there is also positive negative, there is also positive negative, they get cancel each other. Okay, I mean they get neutralized, and when they get neutralized, then what will happen? The charge appear at its two end, I mean at the nearest and the farther end. The opposite sign appears at the nearest end, and the like sign, I mean the like charges appears at the farther end. And these charges which are appears here are said to be the induced charge. Are you clear or not? Are you clear or not?
Yes, sir.
Yeah. In this case, you can look at here, we have taken a neutral body and we are carrying a positively charged body near this neutral body, causing which the charges available upon the body gets polarized. Okay. So then due to polarization, the negative charges start to appear near the positive charge body, and the positive charges are repelling, so they start to appear at the further end. Okay. And the charges available in this region are gets neutralized. Are you clear? By the help of this, you can look at here, we got some charges like positive charge at the positive charge end, at this glass rod, and the positive charge appears at the further end, and these appeared charges are said to be the induced charges. Are you clear? And now please note it down. Please note it down.
Done, sir.
Okay. All of you have done it?
Yes, sir.
Okay, good.
Yes, sir.
Now, let's take another example. You have a body, a neutral body. This is your positive and negative charges are available like this. Okay, this is your another example. And now we are carrying a negatively charged body near it. We are carrying a negatively charged body near it. This is a negatively charged body. Okay, or you can also say this is a negatively charged rod. I am writing here negatively charged rod. Okay, then what will happen? Just 1 second. This is a negative, just 1 second. This is a charged body, and after some time, we are carrying a negatively charged rod. Then what will happen? The negatively charged rod start to attract the positive charge towards its closer end, and the negatively charged R appears at the further end, and the charges available in this region are gets neutralized. These charges gets neutralized, causing which we got some induced charges, positive charges at the nearest end of the negatively charged rod, and the negative charges at its further end. Are you clear? And these charges are said to be the induced charge. Are you clear or not?
Yes, sir.
Yeah, good. So this is a method by the help of which we can charge a body. Okay, and this method is said to be the charging by induction. Are you clear?
Yes, sir.
Remember here, induced charge is temporary. Induced charge is temporary. Okay, it is not a permanent method of charging. And remember that the charge available on this glass rod is said to be the inducing charge. This charge is said to be the inducing charge, and the charge available, the charge induced is said to be the induced charge. So it is also important to remember here the inducing charge always be equal to the induced charge. Inducing charge always be equal to the induced charge. Next point, the induced charge exists in pairs always. You can look here. These are the positive and there is a negative charges. Are you clear? So we can say induced charge exists in pairs. And next point is in conductor, if the body is your conductor, in this case, induction, you can say induction, or it is also known as polarization, is of 100%. Whereas in dielectric, if the body is dielectric material, dielectric in the sense non-conducting body. Are you clear? The body is not a conductor, non-conducting. Okay. In this case, induction, or you can say polarization, always be less than 100%. Are you clear? So please note these important points also. All of you have noted it?
Yes, sir.
Can we move on? Can we move on? Jereen, Mansi,
Yes, sir.
Nida, Rufia. Can we move on? All of you have noted it?
Yes.
All right. Now, take a question here. In this question, there are two spherical bodies are given. Two spherical bodies are given. Okay. And it is saying here, make these sphere permanently charged using induction. Make these spheres permanently charged using induction. Okay. This is your body A and this one is your body B. Then can anyone tell me how can we make these bodies charged by the induction method? What will be the process? Anyone? Then look at here. First of all, we are going to keep these two bodies in contact with each other like this. The first one is the body A and the second one is the body B. In the second step, we have carried out a positively charged body near these two bodies. Then what will happen? The charges available upon this body, sorry, the negatively charges appear available upon this body start to appear at their nearest end of the glass rod, and the positive charge start appear at the further end of this body. Are you clear? After then, what we should do? We are going to separate these two bodies. Once of we are going to separate these two bodies, but it is also remember here, first we separate these two bodies A and B from each other, and then we will remove this glass rod from here. Okay. What we are going to do? We are going to do, first of all, we are going to separate body A and body B from each other, and then we will remove this glass rod from this position. Okay. So this is your body A and this one is your body B. We have separated these two bodies from each other at some separation. Now the negative charges are at this point and the positive charges are at this point. This one is body B and this one is body A, and this is your positively charged rod. Are you clear? And now you should remove this positive charge rod. Then what will happen? When you will remove this positively charged rod, then this is your body, this is your another body. Then what will appear? Then what will happen? The positive charges are start to come at this position when the separation between these two bodies are very small. So it is also remember that these two bodies always kept at some separation from each other. And when you put this body at some separation from each other, in this case, this is your body A and this is your body B, your charge will distribute uniformly throughout the body and your body becomes charged. Body A becomes negatively charged and body B becomes positively charged body. And we can say we get two different charge bodies. Are you clear or not? Are you clear or not?
Yes, sir.
Yes, sir.
All of you are understanding this or not?
Yes, sir.
In step 1, we have kept bodies in contact. Okay. In second, we have carried out positively charged rod. Okay. In the third step, okay. In the third step, we are separate bodies from each other, keeping positive rod as it is. Okay. And in the fourth step, now remove positively charged rod. Okay. In the fifth step, keep bodies at sufficient separation. Okay. At sufficient separation. Are you understand it or not? Are you clear? Hello.
Yes, sir.
Hello. All of you understanding or not? Mansi,
Yes, sir.
are you understand it?
Yes, sir.
Akshay, Nida, Rufia,
Yes, sir. Understood.
all
Yes.
of you are understanding? Okay, good. Please note it down. Please note it down.
Done, sir.
Okay, good. And now the next point is earthing or grounded conductor. It is also known as grounded conductor. Okay. Earthing or grounded conductor. Right? What is the means of earthing here? In electro, the earthing means we are going to make the potential of a body equal to 0. Are you clear? What is the means of earthing? Earthing in the sense we are going to make the potential of a body equal to 0. Are you clear? So please note it down. Earthing means that the potential of a conductor, has been made equal to 0. The potential of the conductor has been made equal to 0. We are, suppose that, just one second here, please try to understand here. Suppose that you have a C. Are you clear? Now, can anyone tell me, I am going to pour some amount of water. This is a water bucket. I am going to drop this all of water into the sea. Then can anyone tell me what will be change you can observe in the level of the sea? Anyone can tell me? Does the level of the sea will change or not? You are pouring one bucket of water only. Then does the level of the sea will change or not? Anyone? Hello?
No.
No, exactly. Why? Because sea is also a big reservoir of water. I mean, are you clear? In which infinite amount of water is available, right? So there will be no change in level will be observed. Are you clear? Just like this, Earth is a reservoir of electric charges. Are you clear? Earth is a reservoir of electric charges. Are you clear? You can observe this phenomena in your houses or in your home, like from all of the switches or from all of the electric board panels, okay, a neutral wire is provided due to the reason of safety. Like in the case of rainy season, sometime it may be happen that some electric charges start to leak, causing which to prevent the electric shock, a neutral wire is provided there. Okay, through that neutral wire, all of the charges are transferred from your electric panel to the earth, due to which you are safe. Are you clear? All of you are clear or not?
Yes, sir.
Yeah. So please mention here, earth is a reservoir. Earth is a reservoir having infinite charge. Having infinite charge. And the potential of earth is 0. Next point, potential of an earthed conductor. Potential of an earthed conductor is also 0. Okay? Please note it down. Please note it down.
Done, sir.
Okay, good.
Done, sir.
Now let's take an example. In this example, we will see how can we make earthing or earthed a conductor. Okay. Take a conductor, and this conductor is put at a stand. Okay. This conductor is kept at a insulated stand. Remember here, this is your insulated stand. Okay. And now, upon this conductor, there is only 3 positive charges are given. I hope you have remembered that from your last classes, the positive charges never move. Why? Because they are always tightly bounded with their parent nuclei. Okay. This is your conducting body, and which is kept at an insulated stand like this. And now we are going to connect this body to the Earth's surface. This is your positive charge. And you have already know positive charges can't move, causing which from this earthing conductor, this body start to attract some negative charges. And how much amount of negative charges it start to attract? It always be equal to this amount of positive charges, causing which now you can look at here, the positive charges and negative charges are equal. So finally, this body gets neutralized. Finally, this body gets neutralized, and the net charge upon this body will be Q is equal to 0, and potential also be equal to the 0. Are you clear?
Yes, sir.
Yeah. It is also, remember here, if a body have if the charge of the body is 0, okay, then it doesn't means the potential also be 0. Are you clear? It may also, it may not be 0 also in some cases. Are you clear? Potential may not be 0. Okay. There is no matter what is the charge upon the body. Are you clear or not? So please note it down. And what is your next example? The next example is, in your next example, we are taken negative charge upon the body. Negative charge upon the body. And this body is also kept on an insulated stand. In the second step, we are going to connect this body to the Earth's surface. This is your Earth's surface. In this case, Negative charges, you have already know, negative charges can move, okay, causing which they start to go into the earth. Negative charges start to move into the earth, and at a final moment, the net charge available upon the body is 0. Hence, we can say V is equal to 0 and Q is equal to 0. I mean, the potential of the body becomes equal to the 0 and your body gets neutralized. Are you clear?
Yes.
Are you clear or not?
Yes, sir.
Yeah. Please note it down, whole of this part. All of you have noted it?
Yes, sir.
Yeah. Now the methods of charging is over. Okay. And we are going to start a new point, Coulomb's law. Anyone of you can tell me what is the Coulomb's law? Coulomb's law. What is the Coulomb's law? Anyone can tell me?
And the force of attraction or repulsion between two stationary point charges.
Exactly. Okay. In short, or in the simple way, we can say the Coulomb's law gives the magnitude of the charges. Coulomb's law can measure the magnitude of force acting between two charged particles. Are you clear or not?
Yes, sir.
Yeah. Coulomb's law gives magnitude of force. Just 1 second. The another simplest way is right here, calculates. Coulomb's law calculates, or Coulomb's law measures. Coulomb's law measures amount of force acting between two charged bodies. Are you clear? And now, what is the statement of the Coulomb's law? What is the statement of the Coulomb's law? It states that the magnitude of force acting between two charged particles or between two charged bodies are directly proportional to the directly proportional to the magnitude of charge. This is your body, this is your charge Q1, and this body have charge Q2. Separation between them is R. Okay, magnitude of charge. So we can write F is directly proportional to Q1 and Q2, and inversely proportional to the square of the separation between them. I mean F is 1 over R square. Okay, this is your equation 1, this is your equation 2. Please note it down first.
Done, sir.
Okay, good. All of you have done this? Okay. Now we have two equations. F is directly proportional to Q1 and the second one is F is inversely proportional to 1 over R square. When you are combine these two equations, you got F is directly proportional to Q1, Q2 over R square. Okay, just 1 second. 1 second. Yeah, you got F is directly proportional to Q1, Q2 over R square, or F is equal to K, Q1, Q2 over R square. Okay, please note it down. Now, in SI system, remember here, in SI system, the value of K is equal to 1 over 4 pi epsilon naught, which is equal to the 9 into 10 raised to the power 9. Okay, Newton meter square per Coulomb square. Or we can also write F is equal to, at the place of K, we can write 1 over 4 pi epsilon naught Q1, Q2 over R square. This equation, this is the equation of the force acting between two bodies, okay, between two charged bodies in SI system. Are you clear? Please note it down. Whereas in CGS system, the value of K is always be equal to 1. Okay. Then F is equal to Q1, Q2 over R square. This equation will be in CGS system. Are you clear or not? Okay.
Yes, sir.
And also remember here, what is the epsilon naught? This is known as epsilon naught. Okay, it is Okay, it's told you permittivity of space. I means the magnitude of force acting between two charged bodies are also depends upon the medium between two charges. Okay, so this epsilon naught told you that in what amount the force is acting between two charged particles in a particular medium. Okay, so we can write here epsilon naught, which denotes absolute permittivity, absolute permittivity of free space, which is your air or vacuum. And remember that the value of epsilon naught depends on the nature of medium. Okay, separating the charge. Okay, and the value of epsilon naught is 8.85 into 10 raised to the power minus 12 Coulomb square per meter square per Newton. Okay, please note it down. All of these points are in SI system. Okay, these all are in SI system. Please note it down.
Noted, sir. Done.
Good. And all of you noted it. Aisha, Akshay, Manasi,
Yes, sir.
Rufia.
Yes, sir.
Yeah, all of you understanding or not? All of you are understanding this concept of
Yes, sir.
Coulomb's law or not?
Yes, sir.
Hello.
Yes, sir.
Yes.
Next point is, remember that this Coulomb's law is applicable for static charges only. I mean, when the charges are in the state of rest, then the Coulomb's law is applicable only. So right here, Coulomb's law is valid. Coulomb's law is valid for static charges. Okay. Second point, magnitude of force is depends on the nature of medium. Nature of medium. And the third point is electrostatic force is conservative in nature. Electrostatic force is conservative in nature. Okay, please note these 3 points also.
Done, sir.
Okay, good. Now we are taking a question. Okay, and by the help of this question, we are going to calculate the force acting between two charged bodies, and also we will try to understand the concept of the charge. Are you clear?
Yes, sir.
We have a question. This one is your charge Q1, which is equal to 2 millicoulomb, and the second charge is this. This is your charge Q2, which is equal to minus of 3 millicoulomb. Okay. Separation between these two charges are 3 mm. And the question is, calculate force acting between, calculate magnitude of force between charge A and B. Between charge A and B. Okay. The next one is your solution. Please try to solve this question.
Okay, sir.
Yeah. Jerin, can you understand this question or not?
Yes.
Okay. And Nida,
Yes.
can you solve it?
Yes.
Okay, good. Rufia,
Yes, sir.
yeah, can you solve it or not?
Yes, sir.
Okay, good. Please try to do this fast.
So is the answer 6 Newton?
6 into 10 raised to the power 6.
Okay. 1 minute.
Yeah, please convert all of the values in SI system first, right? Now, I am going to solving this question. The force, what will be the force acting between these two charge bodies? F will be equal to 1 over 4 pi epsilon naught Q1 Q2 over R square. What is your Q1? What is the Q1? 2 millicoulomb, which is equal to 2 into 10 raised to the power minus 3 coulomb, right? And what is your Q2? Q2 is your minus of 3 millicoulomb is equal to 3 into 10 raised to the power minus 3 coulomb. R is the separation between these two charged particles. This is your 3 mm, which is 3 into 10 raised to the power minus of 3 meter. Okay. So now put all of the values in the equation. 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9. What is Q1? Q1 is your 2 into 10 raised to the power minus 3. Q2 is 3 into 10 raised to the power minus 3 and divided by 3 into 10 raised to the power minus 3 square. Okay. After solving, you got 9 into 2 into 3. What will be this? I think it is 54 into 10 raised to the power 9, 10 raised to the power minus 3 and 10 raised to the power minus 3. It will be 10 raised to the power 3 over the square of 3 is 9 into 10 raised to the power minus 6. Okay. Just 1 second. 9, 6 and minus 6. When you transfer minus 6 in the above, you got 6 into 10 raised to the power 3 into 10 raised to the power 6. This is 6 into 10 raised to the power 9. I think 6 into 10 raised to the power 9 is a correct answer, right?
Yes, sir.
Yes.
Okay. Hello?
Yes, I think so. It's correct.
Yeah. Okay, please note it down.
Then, sure.
Okay, good. Another question. All of you have done it?
Yes, sir.
Okay. The next question is, two charges Q1 and Q2 placed at a separation R repel each other with a force F. Calculate force between them if magnitude of both charges is double and separation between them is half. Okay, please note it down and solve it. All of you can solve it or not? All of you can solve it or not?
So we can solve.
Yeah, good. Please try to do, all of you.
Done, sir.
Done. What is the final answer?
16.
16. Hello. Hello. You are right. Your answer is correct. Tell me, please.
16.
16. Mansi.
16.
Good. 15. No. It is.
16.
Yeah. 16. Good. Okay. Anyone else? Anyone else?
Sir, my answer is wrong.
Okay, good. No issue. Okay. Uh, let's try to understand. In this question, there are two different parts. Okay. It is depends upon you that in what way you are observing the questions. Okay. The first part is this. Two charges Q1 and Q2 are placed at a separation of R, repels each other with a force of F. Right. Then what will be the equation? In the first case, it will be F is equal to K Q1 Q2 over R square. Are you clear or not? Right. And in the another cases, it is saying here, calculate the force between them if magnitude of both charges is doubled. I mean, Q1 becomes 2Q1 and Q2 becomes 2Q2 and R becomes, separation between them is half. All of you are seeing on the screen, separation between them is half. Then R will be R over 2. Okay. Now, what will be the second equation? It will be, suppose that we are taking like F dash, because we have already taken F in the first part. So F dash is equal to K. Q1 is 2Q1. What is the value of Q2? It is 2Q2. What is R? R is your R over 2 square. Now, F dash is equal to 2 into 2 will be 4. We are taking the 4 from outside. 4K Q1 Q2 over what is R over 2 square? It will be R square over 4. And finally, you got 4K. Sorry, this 4 you will transfer from denominator to the numerator. You got, one second, you got 16. 4 into 4 will be 16K Q1 Q2 over R square. What is this part? This part is F. So we can write F dash is equal to 16F. Are you understand? All of you are understand it or not?
Yes, sir.
This is your final answer. Please note it down, all of you. And now just I am asking to all of you that the concept of vector is clear or not? All of you. Please tell me.
Yes, sir, it's clear.
The concept of vector is clear or remember or not?
Yes, sir. It's clear.
Yeah. Do you know I cap, J cap, K cap,
Yes, sir.
unit vectors? Do you remember or not?
Yes, sir.
Okay. All right. Good. But just for revision, please note it down. Then we will start. Okay. Note it down first.
Okay, sir.
Okay. Good. Should we move on? Now, there is some concept of vector which is important to remember. Vector. This is your this is a unit vector. What is the unit vector? Can you tell me? A vector of magnitude. A vector of magnitude 1. Are you clear? The formula of unit vector is vector of the formula of unit vector is unit vector of A is equal to vector of A over mod of A. Okay. This is your formula of unit vector. And you have already know the next point. This is your I, J, and K cap. Okay. In X direction, we have taken I, and this is your J, and this is your K cap. Are you clear? And you have already know I dot I and J dot J and K dot K is equal to 1. Do you remember or not? All of
Yes,
you are
sir.
remember or not? I dot I is 1, j dot j is equal to 1, k dot k is equal to 1. Are you clear or not? And
Yes, sir.
in the, okay, this is your dot product. Okay, from dot product formula. And in cross product, I cross j is equal to k, j cross k is I, and k cross I is equal to j. Okay? Are you clear?
Yes, sir.
Okay, good, good. Okay? This is your cross product formula. Please note it down just for remember only. Okay, because we have a requirement in the further part of this Coulomb law. Okay, please note it down. Can we move on? All of you have done this.
Yes, sir.
Now, the next point is dielectric constant and relative permittivity. Dielectric constant and relative permittivity. Okay, this is your next part. Dielectric constant and relative permittivity. Okay, can anyone tell me what is the means of the permittivity? I have already told you in the previous PPT. What is the means of permittivity in case of physics? Remember here, okay, permittivity especially measures or determines the amount of force acting between two charged bodies in a particular medium. Do you remember or not? Do you remember dielectric permittivity or dielectric constant? Hello?
No, sir.
Please tell me, all of you, Aisha, Jerin,
No, sir. I don't know.
Manasidas, Rufia, Aisha, Akshay. Please tell me, do you remember or not?
No, sir.
Yeah, remember. Okay, please note down. Permittivity of medium determines the magnitude of electric force. Magnitude of electric force between two charges in medium. Between two charges in medium. Okay. Now, we have already know, according to the Coulomb's law, according to Coulomb's law, in air or vacuum. The formula of Coulomb force is F naught. I mean, the force acting in air is represented by F naught, right? Or it is also sometimes called F0. 1 over 4 pi epsilon naught Q1 Q2 over R square. This is the equation number 1, and this equation is only and only when the charges are available in air or vacuum. Are you clear? When the charges are in air or vacuum. Okay. This is your charge Q1 and the another one is charge Q2. This is your charge Q1 and the separation between the charges are R. Okay. And what is the epsilon naught? Epsilon naught is absolute permittivity. Absolute permittivity of free space. Okay. And what will be the equation when the charges are present in a media? Then in medium, the two charges are present like this. These are the two charges, and these two charges are separated from each other by the help of a media like this. This is a media, and this medium have a constant K. Okay. Between these two charge particle, a medium of dielectric constant K is present. The charge of this is Q2 and the charge of this one is Q1. Okay. When charge is placed in a medium, in this case, F of M is equal to 1 upon 4 pi epsilon. Remember here, we are taken epsilon naught in this equation. You can look at here, but in medium, we are taken for the medium epsilon. The charge is Q1, Q2 over R square. What is the epsilon? Epsilon is absolute permittivity of medium. Okay. Absolute permittivity of medium. Please note it down till this point. This is your equation 1 and this one is your equation number 2.
Done, sir.
Okay, good. Now we are going to divide equation 1 by equation 2. Okay. From equation A over equation B, we get F naught over Fm is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square over 1 over 4 pi epsilon Q1 Q2 over R square. This part is cancelled with this part, and finally you got F naught over Fm is equal to 1 over 4 pi is also cancelled with each other. After transferring the values from denominator to numerator, you got epsilon over epsilon naught, which is also known as K or ER. What is the K here? K is known as the dielectric constant. This is your dielectric constant, and ER is relative permittivity. Relative permittivity. Okay. Are you clear? Or from this equation, you can also write E over epsilon naught is equal to K, or E is equal to K epsilon naught. I mean, if the permittivity of air is given, then you can calculate the permittivity of media, or you can also say if the permittivity of media is given, then you can calculate the permittivity of air. Are you clear or not? This is your equation number D. Not D. This is your equation number 4. This is your equation number 3. Okay. Are you clear or not? Now,
Yes, sir.
substitute this equation 4 from equation 2. Then what you get? On substituting equation 4 from equation 2. What is the equation 2? F of media is equal to 1 over 4 pi epsilon Q1 Q2 over R square. What is the epsilon? Epsilon is K epsilon naught. From this equation, you can look at here. Then it will be Fm is equal to 1 over 4 pi K epsilon naught Q1 Q2 over R square. Are you clear? This is also a formula of in case of the media, okay, in which the permittivity epsilon naught is the permittivity of, if the permittivity of air is given and the dielectric constant is given, then you should use this formula. But if the permittivity of media is given only, then you have to use this formula. Are you clear or not?
Yes.
Permittivity of media is given, then you should use this formula. Are you clear or not?
Yes.
Yes, sir.
Yeah. This is your dielectric constant. This is your permittivity of free space. Okay, please note it down. Also, just 1 minute. Give me 1 minute. Also, from this equation, you can also write F naught over Fm is equal to K, or here mention here from equation 3, we have also F naught over Fm is equal to K, or F naught is equal to K of Fm. Okay, it is also equation in terms of force. Okay, and this is in terms of the different part like the charges and the separation also here given. Are you clear? Please note it down.
Done, sir.
Okay, good. And now remember here what is the value of K. The value of K is always be given in your question, but here I am giving you some information about the value of K. I mean dielectric constant. The dielectric constant is 1 for air, and the value of dielectric constant is 80 for water, and the dielectric constant of conductor is infinite. Okay. Also write down here. And some definitions from F0 over Fm you have already know. It is saying here that dielectric constant or relative permittivity is the ratio of the force between two charges, ratio of the force between two charges, okay, in vacuum to the force between same charges in medium. Okay, please note it down. All of you have covered it or not?
Done, sir.
Okay. Then all of the concept, okay, of this lecture is understanding or not?